Okay, hi everyone, I'm Dominik. I work in the Blink layout team, and welcome to the text and layouts overview for BlinkOn 5. Slides should be shown. No, it's there. Right, so let's get started. Oh, sorry. It's a bit embarrassing on a text and layout session. Something's wrong with my slides here. No characters showing. Let's load a font. Oh, here we have a font. But now something else went wrong. Now it's in Arabic. I don't want to do this talk in Arabic, but it's now displaying right to left. But I don't know. I still need to fix something on my slides here. It's like, I'm sorry about that. It's now really like pixelated. Something's wrong with the spacing. You see the words are a bit off, and yeah, encoding issues, right? My last name doesn't show correctly. Now that's fixed. It's a bit better. Like we have no anti-alias text. It looks nicer. Still something wrong with the encoding. Oh, okay. Getting there. Oh, again, like text and layout is really tricky sometimes. So now it's vertical text.
Yeah.
Vertical text and the characters are upright. It's a little bit hard to read. Maybe. Oh, okay. Almost right. But maybe like this. But okay. Finally, we got there. So this was a bit of an overview of what can go wrong in text and layout, and this is the kind of stuff we in the text and layout team are dealing with on a daily basis. What I want to talk is about goals and challenges in text and layout. What does the font code do that we're working on day to day, and recent improvements and future plans. So challenges of text and layout, which is an incomplete list. There's a lot of complexity resulting from the fact that CSS provides so many options for styling and sort of ways of integrating fonts. There's a lot of dependencies with, for example, the loading code when loading web fonts. There's dependencies with the stages of layout above the code that we try to improve. So there's a lot of interactions with the surrounding text. So text can also be updated through JavaScript and so on. Another challenge is that we always need pixel precision, and sort of subtle layout bugs can lead users to think that there's something wrong, there's something feels odd about the text without them being able to really put the finger on that. We want to do optimal font matching and fallback. We want to shape not only Latin script languages, but all languages that there are, ideally. You saw that it can be challenging to do vertical text right. Performance needs to be right, and we want to enable as much as possible of the typographic features that OpenType and other font systems provide. And the goal with that is we want to have correct and consistent display of all text, high performance in complex text processing, and low overhead and cost for advanced typographic features. So let's look at the font code a little bit. What does it do? It basically does three different things. It measures text, it draws text, and it's responsible for helping with text selection. So the biggest one is, or the most important one, is measuring text, so that the layout stage can use these measurements. Now, perhaps intuitively, you would think this is how you measure text, right? You have a font, you have a size, and you have a text, and then you're done. It turns out there's a couple more variables involved. So there is font, there is size, but we'll go through these one by one. So the concept of a different font is quite clear. I think like we have, for example, here times for a proportional font, source sans, something as like a monospace font for displaying code or other things, and then a decorative font like Lobster, which you can see has is a bit more visually appealing, perhaps, and used for design. Then font size is also pretty clear. pixel sizes in CSS, other ways of specifying that. Then direction. In the Arabic example at the beginning, or the examples with vertical text, you see there's left to right, right to left, top to bottom, bottom to top, where bottom to top is mainly for sort of the sake of completeness, but not practically used a lot. Features. Features are ways of a font to allow for sort of more stylistic variation. Small caps, ligatures, swashes, ornamentals, different ways of displaying numbers depending on their usage. And you need to take that into account because the shape can vary when you use these features. Script is the writing system. So every language can be expressed in its primary script. So Western languages would be expressed in Latin script, Arabic in Arabic script, and so on. Then there is one special script, or actually there are two special scripts. One is common, and this is used for punctuation characters or similar, where the character takes the script of the adjacent sort of primary script. So, and language is important when shaping text or when measuring text. So here's some example: English, German, Finnish are expressed in Latin script. Even though with Finnish, sometimes you think it would need its own. Azerbaijani can be expressed in Cyrillic, Latin, or Arabic, Chinese in traditional and simplified, and the list continues. These are just some examples to illustrate that the relationship is not always one-to-one. And then the text and the context. So I've highlighted the text red, and I've highlighted the context blue. Now, in this kind of English example, it's relatively clear that if you would block out the context, the length of the sort of hello world text wouldn't change. But let's look at an Arabic example. So here we have an Arabic word, and you would see that if I remove the context, the length will actually change. So it looks like this when I split it out. So what you see is, for example, that this character here takes a different shape depending on whether it's joined with this adjacent context. So this is important in layout when we're measuring these things, because then when you remove the context, the length changes. You need to take into that. You need to look at that in the layout. So this was measuring text again. Let's look at this formula, keep it in mind. So this formula is the length is dependent on all these other 7 variables. And when you ignore some of these variables, you will run into problems. And also, one important thing is that you can only measure text if you know the values of all these variables. Okay, drawing text is about bringing the glyphs from the font to the screen. Again, our Arabic example, so these glyphs are contained in a font file as vector shapes. So we want to know where to draw them on the screen. Let's say layout has determined that this is our starting point for drawing this run of text. So then we need to know how far do I place the next glyph from the font. So we need a data structure that keeps this information. The data structure should contain information about which glyph I want to draw and where. And here in this example, it's just a horizontal axis. So we just store the advanced width, which is what it's called. Now here we have an example of a string or like a run of text which has several glyphs. But you see, they have these combining marks. They have this rev and the cedilla and this kind of ring here. So these are actually different glyphs in the font. So you could roughly think about them as separate glyphs. This combining mark here, and this cedilla and the ring, and this character, this glyph, they are all different in the font. So now you need to actually know where to place them, not only horizontally, but also sort of on a vertical axis. And Glyph Buffer is a flexible data structure that we have in Blink, which keeps the glyph information and also the sort of coordinate information for drawing runs of text. And it can take two shapes, one where it's only storing advanced width and one where it's taking a sort of into account vertical coordinates as well. So the Glyph Buffer is our sort of working data structure there. So we use that for measuring and for positioning. And also we use it for selecting text. So when you move the mouse cursor over a run of text, then you can use the Glyph Buffer data structure to determine your selection range. Now, one thing important here is we're transforming between swing coordinates that the mouse cursor gives us and character position, not only glyph position. So I'm not sure about this example, but in general, character position is not identical to glyph position. So character position is your position in the input string, whereas glyph position would be sort of the visual segmentation. So that's the conclusion for what the font code does. It does measuring text, drawing text, selecting text. I'm going a bit into detail here and into this kind of context to have a better angle of explaining what we've been improving. So generally, the process from getting from an input string to the Glyph Buffer, which has all this information, is called shaping. So keep in mind this example of Arabic, where removing the context breaks the correct sort of measurements of positioning. And keep in mind that the shaping also determines basically the horizontal and vertical positioning of glyphs, the units of a font. We have two shapers in Blink. We have simple and complex shaping in Blink. And what I was saying about this formula is important here. The simple shaper is basically ignoring a few of these variables as an optimization. So as I mentioned in this example about Hello World with lorem ipsum around it, you can make assumptions about English text without certain typographic features and say like, okay, I don't need the context here, so I can do faster shaping. That is the assumption. So, so the simple shaping cannot do something like this. It doesn't take into account context, and that's why you end up with all the isolated forms of these Arabic characters, but not the sort of medial forms that you have here. Also, in a decorative font that supports sort of ligatures, you see here perhaps that this simple shaping does not form any ligatures here, whereas in complex shaping with typographic features activated, it actually forms ligatures here. This grapheme cluster here is just for sort of as a teaser for what's happening next. So we look at a little bit like what happens when there is no appropriate glyph to be found in the font. So as a summary, or as a sort of quick look into the data structures involved, we have a font family specified as lobster, sans serif, and we have an Arabic input string. Then we go into a data structure called glyph page tree node to find individual glyph information for each of these boxes in our glyph page tree node, and we find them only in the fallback font because lobster and sans serif don't have these Arabic ones. But it's important to keep in mind that this lookup happens for each character on an individual basis. So as a summary, the simple pass does typewriter style glyph selection for each character. So typewriter style, because you just like in a typewriter, you place the glyph by just putting one block there and then moving forward. You don't look left and right for context. The complex path does shaping and contextual glyph selection. The simple path does horizontal advances only, and the complex path does 2D glyph placement. So in the example with the combining marks, you also have vertical coordinates. The simple path does not provide control over typographic features. There is sort of hacky kerning support, I think, but it's not working very well. Complex path does full typographic feature support. You can activate open type features as you go. The simple path fails on scripts that require contextual shaping, so it doesn't support Arabic, for example. Complex path does comprehensive script and language support. So that's kind of for the background a little bit. So what we've done recently in text and layout, or what have we done there? So we're switching to complex text for everything. And to avoid performance regression there, we introduce a concept called word cache. We do shaper-driven segmentation, and I will explain what that is. And we're improving font fallback, and we did a lot of work on improving specifications revolving around vertical text. Switching to complex. So why do we want to do that? You can imagine if you have two code paths doing a very similar thing, you end up with slight differences between them. And this leads to like very subtle bugs and very annoying bugs, and because they're sort of hard to explain to the user. Because the user doesn't want to hear an explanation like, sorry, we have two code paths and we're choosing the wrong one, or the other one is doing the wrong thing. So there's not really a justification for these bugs. And it's hard to maintain these two code paths at the same time in terms of getting comparable performance results and correctness results. So we want to unify that code. We want to make advanced typography always available. And we want complex script languages to become first-class citizens so that there is no extra performance overhead for running those. Full shaping, however, is more costly. You can imagine you need to do more processing on the input string there. So it's mandatory to avoid performance regressions, which we do with a word cache. So in simple terms, and there are experts in this room who can explain this a bit better than me, but in simple terms, what you want to do when you want to break this input stream here at this boundary is you're measuring how long is it, and you find the breaking position, and then you measure maybe maybe I can fit this much of the string in it, maybe I can fit this much, no, still that's over, and then, okay, I can fit this much. So I'm done here, and I would break at the sit, and my layout for this line is done. What you see here is that there's a lot of redundant work here. Like this part of the input text is shaped always again. It's like you computing the result for this over and over, even though you would probably know that once you've done this, you know already how long the first part of the sentence is. So that's the concept of a word cache in short. So basically, we're finding all the spaces, segmenting by that, and then shaping each word individually, putting that to a cache, and then this helps us with answering the queries that we receive for the font code, like what's the width of, for example, this part, and we can answer the width of this is the width of these added up plus the width of these spaces. The next thing that we improved is, or that we introduced, is shaper-driven segmentation. And again, going back to the formula, for the formula to work correctly, you need to know all the values that go into it. So there's the font size, or the font, the size, the direction, and so on. So for one round of shaping, all of these need to have a constant value. So if you have text that has multiple scripts in it, you need to segment it first so that you can run shaping. And we've transformed this into a process where this segmentation process is also controlled by the shaper. And the shaper means the library that does shaping for us. And we're using half-bus to do this for us. To talk about shaper-driven segmentation, let's take a step back and look at font coverage. Here is a list of example fonts. We have Koji Minshu, Logic Devanagari, sans serif, which is a way of specifying you want a font without serifs. And this usually maps to Arial, for example. Apple Color Emoji, these are Pro. And they have different coverage. And the coverage is expressed in a table called CMap. So you have all the Unicode characters, and the font tells you for which one it has glyphs. So for which one it has symbols. Koji Minshu sort of has, let's say, glyphs for the CJK range of languages. Lohit Devanagari covers Devanagari script. Arial has a bit spotty coverage here and there. Apple Color Emoji covers emojis. And Visa Pro covers some Arabic. So what happens when you have an input string is you need to map your input string to which font supports drawing it. And this is a process called font fallback. Now in the page, the author of the page has specified 3 fonts, Kochi Mincho, Lohit Devanagari, sans serif. But you see already that our input text is a little bit, has a wider spectrum than that. So for each segment of this text, you go and find the suitable font. And you start by looking at those that are specified. If you run out of these, or if these can't cover it, what you could do is can place the boxes that were on the first slide of my presentation, or you could try to be a bit better than that and find something appropriate. So, Kochi Mincho, let's start with this ABC. You go top to bottom here. Kochi Mincho does not have coverage for ABC. Lohit Devanagari doesn't. Arial has, so this segment gets Arial as the used font, and this is even in the list that's specified. Again, for this run of text, we do the same and we find coverage in Kochi Mincho. Let's look at the emojis. We try with those 3 that are specified here in CSS, and we notice none of those fonts has emojis. So we need to do something called system fallback and find something from the system and try to express or kind of try to draw these characters with something that we find. And here we find Apple Color emoji, and it works. The same for this Arabic text, we find the system fallback Visa Pro. So not only by, so you see here it needs to be segmented, not only by the other variables of the formula, but also by font coverage. Now before, what we did there, if you have an example input string like this, we would hammer this glyph page tree for each of those characters and ask, do you have a glyph for this? Do you have a glyph for this? Do you have a glyph for this? In a per character fashion. That also means that in the example with the sort of base character E plus combining marks, base character A plus combining marks, we would hammer this glyph page tree data structure and ask, do you have a glyph for the base character? Do you have a glyph for the combining mark? And so on. And what we get is for each character, we get a result with like, yes, I have a glyph. This is the glyph ID. And this is the name of the font that can be used. And then we would sort of group them again. If they have the same result from the glyph page tree, then we can shape this together. We can shape this together. We can shape this together. Thing is, there's a couple of other variables that you need to segment by. For example, here you can see you can segment by script. And the emojis, because they're common, they would be joined with this Devanagari text. Again, here you start with Chinese script, and then this would be joined with that, and so on. So the glyph page tree, this does some magic for all this segmentation. It not only answers whether it has a font for it, but also where are other boundaries in terms of orientation and script. And that makes it very hard to kind of maintain that data structure because it does several things in one, and it's not in the right place architecturally. So that was how it used to work, and now I'm talking about what we introduced as improvements. So first we have a clean run segmentation stage, and it's always easier to keep longer segments of text together. In terms of performance, it's easier. You don't need to do so much sort of individual character handling. So we have a run segmentation stage that segments by script, by orientation, and by, in a way, typographic features which are activated. So you get a result of, in this case, 5 sub-runs, and then you come to the stage of actually shaping those. You can imagine now for these, all the variables that go into the formula are constant except font. And that's what the next stage is about. So that's that's why we're introducing shaper-driven segmentation for font fallback. So I've picked I've picked the second run from here, and now I'm trying to put that through the shaper. I know already this is Devanagari script. I know which primary, or I know the CSS font declaration, which I'm going to use for this. And now I'm trying to get the Glyph Buffer through the shaping library. Now, the first font I'm supposed to try, as CSS tells me, is Mincho. And it doesn't work, because there are no glyphs for that in for that string in Mincho. Though Devanagari font covers this. So we have a shaping result for this. So we can create a partial Glyph Buffer. But it's still missing the emojis. And the shaper has told us, I don't have a result for this. So then that triggers another round of font fallback. And we come with the emoji font, and we have now a second result. And we can combine that into a shape result for the whole subprime.
Sorry, I have a basic question.
Sure.
So what is the scope of the job of the shaper?
The scope of the job of the shaper is to transform an input text into the sort of Glyph Buffer data structure, like getting the coordinates, getting the length. And it can only do that once you've reduced all the other variables. It can only do that for one font, one size, one language, and so on.
Okay.
Does that answer the question? So now how does that affect the user experience? So before, someone filed a bug about this. This was someone who wrote a virtual keyboard for his web page and used the web font from Google Fonts. Web font was called Tynos. And yeah, he or she wanted to create this virtual keyboard so that the user can click on these buttons to type maybe less used characters. What happens here is that each of these boxes is actually drawn with two fonts, and that's because of this per character lookup that we had before. So you look up in this glyph page tree node, you find a glyph in the Tynos font for the base E, and then you look up the combining character, and you don't find a glyph in Tynos. And that means now, okay, now they get separated by this kind of grouping stage in the previous code, and now they get drawn as separate glyphs, and that leads to this very strange behavior, where the combining mark is slightly sideways of the base character. So you get something like this. The things don't line up, so the combining marks are sort of slightly off-center. They don't sort of join with the glyph, so it looks ugly. After these improvements on shaper-driven segmentation, it looks like this, how it should be. It doesn't use the web font, though. All of these are now rendered in times. And that's because the web font is so-called subsetted. It only has certain sort of a reduced character map support. Google Fonts has an API for specifying the sort of the critical text that you want to ensure that it gets displayed. And with that, you can fix the web font to cover all of these combinations. But in general, we're now achieving a much better result so that always a sort of readable and visually more appealing sort of glyph is displayed. Yeah. So it looks like this. For sans serif E, you get the right kind of combining marks. They don't get mixed. For example, this one plays here, so they don't get mixed up. Everything's in order. And there is one thing more that we gain from this improvement is shaping across font fallback. So in this test case, we've reduced the font coverage to contain only the middle characters here and only this end character here. And then we have a fallback font which supports the rest. So what happens in the shaping stage, this gets shaped, but this doesn't. This gets shaped, but this doesn't with the first font. Then we fall back, use the next font, and then shape these separately. However, that leads to context getting lost, shaping being off. With the new code, we can improve that, and even if we have font fallback boundaries here, it still sort of displays in a more readable way. Yes, and with that we come to specification work and improvements. So one thing you want to think about before font fallback is actually, do I really find the right fonts that the page author has specified? And the CSS fonts module section 5.2 talks about a priority algorithm for matching a CSS font request with the fonts that you have available, for example, specified in font face and so on. So it specifies you choose first the most appropriate stretch value, then style, weight, and size. And then you have your result with which you go and try to shape the text. So we had several issues with that. For example, we didn't do any stretch matching, and we had some issues with the priority order here being violated. So that means you actually make a mistake in finding the right font, and you, for example, do accidental fallback where it wasn't necessary. Or yeah, you have other sort of artifacts in choosing the wrong font. And then Koji has done a lot of work in terms of vertical text. So by the way, this shaping improvements also brought improvements how we do vertical text. So Koji has worked on the CSS writing mode specification, which specifies some parts of the orientation, so that you don't have problems like on my sort of fourth or fifth slide at the beginning. So that orientation is right. And we're now unprefixing writing mode in WebKit, in Blink. So we don't have WebKit writing mode anymore, but sort of unprefixed writing mode. Yeah, the prefixes can be confusing. And path rate is improving, and Koji helps a lot with getting the specifications right for this part. So this is the summary again. So we are switching to complex text to allow typographic features and complex languages all the time to avoid performance regressions. With that, we have a word cache. We have shaper-driven segmentation to improve things like combining marks, mistakes, and things like sort of keeping context across font fallback. Fallback itself has been improved, but this is sort of work that continues, and we have spec compliance improvements in the area of font matching and vertical text. Future plans. This data structure that I was talking about, Glyph page tree, we don't like it, and we want it to be gone. So this work was sort of precondition for that, and so once complex text is fully switched to and shipped, then we can remove simple paths and all the sort of code that revolves around that. We will still want to improve fallback a little more. So the way we ask for a fallback from the system can be improved. We can get better results from system APIs there. We want to improve testability, so maybe have a better way of doing a sort of black box layout test, but sort of have unit tests for parts of this. And we ideally want to improve our hit rate on the word cache and caching there. Yes, thanks for attending. I'll take some questions. Yes?
How do we deal with different text encodings? Do we just try and encode them all to Unicode so we can do a character lookup that's the same across
Yeah, encoding is actually at a very early stage. So we have a meta tag or an HTTP header that tells you the encoding of the page, or you don't, and then you try to sort of make an estimate about it. But then at the stage of where we come to shaping, everything's in UTF-16. Yes.
How do we compare it to other browsers?
Yeah, yeah, we do compare to other browsers. I think here one improvement is kind of keeping shaping context across fallback. This is something that we get right now. I've seen other browsers fail at that. Generally, I think our correctness revolving around the CSS font specification still has, we have to catch up there. I think in some cases, for example, in fallback, Firefox is doing it slightly better because like they have curated font fallback lists. And you can imagine if you, in that shaping stage, if you have to go through a lot of font fallback options, then you also decrease performance. So there is a bit of tweaking required giving them the right number of fallback fonts so that you have good coverage, but not trying too many because then it's going to be endless. For example, if you ask font config on Linux for fallback fonts, you can get a list back with 1,200 fonts or something. So you can't go through all these. At some point, you just want to give up. Yeah, and there's more ways of comparing this. I think in vertical text, we're also doing pretty well. So there we're also better than other browsers, but yeah. Okay.